In this video, we are going to be doing example 2.8 in the AP Physics textbook, page 39. This problem is called, Watch Out for the Speed Limit. A car traveling at a constant speed of 45 meters per second passes a trooper hidden behind a billboard. 1 second after the speeding car passes the billboard, the trooper sets out from the billboard to catch it, accelerating at a constant rate of 3.00 meters per second squared. How long does it take her to overtake the car? So, remember, our first step is to visualize the problem, and I've already started drawing it out for you. Here is the billboard, the trooper, and the car. And the car is going at 45 meters per second. Okay, so this is when the trooper passes the when the car passes the billboard. Now, the trooper does not set up until 1 second after that happens. So, 1 second later, the car will be, let's say, here. And the trooper will start off at 3 meters per second squared. And then at some point further down the road, the trooper and the car will be in the same spot at the same time. So what I wrote just now is going to be the key to this problem. All right, what's next? Next is to check to see if we need to convert anything, and it looks like we don't. Everything is in consistent units. So then you need to write down your knowns and your unknowns. So we know the speed of the car. So let's call that VC. We know the acceleration of the trooper. Let's call that AT. And then what are we looking for? We're looking for the time. So let's write T equals question mark. Now, you may not really know where to go from here. Now, like I said earlier, this is the key. The trooper and the car will be in the same spot at the same time. So what we need to do is set up an equation for the position of the car, and we need to set up an equation for the position of the trooper. If we set those equal to each other, because they'll be in the same spot at the same time, and solve for time, we can easily solve this problem. So, first thing is we're going to count this 1 second later as time 0. Okay, and the reason we're going to do that is because the trooper doesn't even enter the problem until this 1 second later in terms of motion. So, what we first have to figure out is how far this car will travel in 1 second. And that's pretty easy. So we know from our 9th grade equation that distance equals speed times time. And if the speed is 45, the time is 1, then the distance is going to be 45. So at this point, we've got 45 meters. Okay, so the initial position of the car is going to be 45 meters. So let's call that xi. However, we don't know the xf of the car, or that's the equation we're trying to set up. And we know the acceleration of the car is 0. So we have some more knowns and unknowns, so we can figure out which equation we need to use. And it looks like we should be using that second kinematic. So for the car, we have XF equals XI plus VC, that's just the speed of the car, the initial speed of the car, plus 1/2 AT squared. Now we know immediately that this term goes away because the car is not accelerating. So we can just plug in what we know. We know XI is going to be 45. Again, that's because we're calling this position 0. And then this is position 45. Okay, sorry, let's get back to this. So we know VC is 45, and time is what we're looking for. So there's our equation for the car. Now how about for the trooper? Well, we still want to be using that second kinematic. So for the trooper, this term goes away because its initial position is 0. This term goes away because its initial speed is 0. So we're left with XF equals 1/2 times the acceleration, which is 3t squared. And that's just going to equal 1.5 t squared. Now we can set this equation and this equation equal to each other and solve for t. So it looks like this is another problem where we have to use the kinematics. We have to use the quadratic equation. So let's put this in a form that's more recognizable. So this is going to be 1.5 t squared minus 45t minus 45 equals 0. And again, I'm going to plug that into my quadratic equation solver on my smartphone. And you'll see, I don't know if you guys can see that very well, but you get t equals 30.97 and negative 0.97. So in this case, we just want that positive solution there. And we have our answer. One thing I'd like you guys to think about is what that negative 0.97 means. See if you can come up with an answer.